Hello, my dear students. Welcome to IKSR chemistry classes. In this video, we will discuss the analysis of vitamin C tablets. Please watch the full video. A problem has been given at the end of video. Solve the problem and submit it in the classroom for evaluation. First of all, introduction of the chapter. The chemical name of vitamin C is ascorbic acid. It is a water-soluble vitamin. It is excreted from our body along with urine. Therefore, regular intake of vitamin C in our diet is essential for proper health. A structure and structural features of ascorbic acid. The structure of ascorbic acid, whose molecular formula is C6H8O6, is given below. It is ascorbic acid. Its structural features are given below. It contains 4 hydroxy groups. 1, 2, 3, 4. 1 carbonyl group. This one is carbonyl group. 1 ether group. This oxygen is attached to 2 carbon atoms and hence it is an ethereal group. 1 carbon-carbon double bond. In actual practice, the carbonyl group and the ethereal group are combined together and they give rise to an ester group. It is a cyclic ester and the cyclic ester is called lactone. Alpha, beta and gamma. Ascorbic acid is a gamma lactone forming 5-membered cyclic ring. This ascorbic acid molecule contains indiol group. 2 OH groups are attached to carbon-carbon double bond and hence it is called indiol. This OH group is primary alcoholic group while this one is secondary alcoholic group. Let us try to write down and understand the IUPAC name of ascorbic acid. This moiety is that of furan and this group is 1,2-dihydroxyethyl. 1,2-dihydroxyethyl which has S configuration. This is S configuration around carbon number 1 and this group is attached to furan at position number 5 and there is R configuration at position number 5 and hence it is 5R 1S 1,2-dihydroxyethyl 3,4-dihydro 3,4-dihydroxyfuran. 2 hydroxy groups are present at positions 3 and 4 and 2 on. Ketonic group is present at position number 2 and there is only 1 hydrogen atom in furan moiety and it is at position number 5 and hence its complete IUPAC name is 5R 1s 1,2 dihydroxyethyl 3,4 dihydroxyfuran 2 5H on. It is a complicated one, but it can be understood easily. Acidic character of ascorbic acid. Ascorbic acid has no COOH group, but it is more acidic than other alcohols, acetic acid and benzoic acid, due to resonance stabilization of its conjugate base. As we have seen earlier, that there is no COOH group in ascorbic acid, yet it is more acidic than alcohols and most of the carboxylic acids, and this is due to the resonance stabilization of the conjugate base of ascorbic acid as explained below. There are some compounds: acetic acid, benzoic acid, ethanol, and ascorbic acid, and their pKa values are given here: 4.75, 4.20, 16. Ascorbic acid has pKa value 4.1 and 11.6. We know that lower the value of pKa, stronger will be the acid. It is obvious that ascorbic acid is more acidic than acetic acid, benzoic acid, and ethanol. This is ascorbic acid. The pKa value of this OH group is 4.1, while the pKa value of this OH group is 11.6. When this hydrogen atom is removed as H plus ion, ascorbate ion is formed, which is the conjugate base of ascorbic acid, and this ascorbate ion is stabilized by resonance. This is resonance stabilized ascorbate ion, and this is why ascorbic acid having no COOH group is more acidic than most of the carboxylic acids such as acetic acid and benzoic acid. Natural sources of ascorbic acid, that is vitamin C. Some food materials rich in vitamin C are given below. Citrus fruits are good source of vitamin C, such as orange. Amla is the richest source of vitamin C. Medicinal values of vitamin C. Vitamin C is a powerful antioxidant. It protects our cells from damage by free radicals. Our cells are generally damaged by accumulation of free radicals in our body, but vitamin C protects our cells from damage by free radicals. The accumulation of free radicals in the body produces oxidative stress and various other chronic diseases. Vitamin C prevents the accumulation of free radicals in our body by neutralizing the free radicals, and thus prevents chronic diseases such as heart disease, oxidative stress, etc. Mechanism of action. Vitamin C is a free radical scavenger due to its ability to donate H plus ion and electron to form relatively more stable ascorbyl free radical. Vitamin C has an ability to donate H plus ion and an electron to form relatively more stable ascorbyl free radical. And due to this ability, vitamin C acts as free radical scavenger. This is ascorbic acid. First of all, this hydrogen atom is removed as H plus ion, forming ascorbate anion. Then this ascorbate anion loses one electron from here, forming ascorbyl free radical, which contains one unpaired electron. This electron is donated to lipid free radical and neutralizes it. And this is why ascorbic acid acts as free radical scavenger and an antioxidant. This electron is donated by vitamin C to lipid radical, and thus lipid peroxidation chain reaction is terminated. During oxidative damage of cells, lipid peroxidation chain reaction takes place, and this chain reaction is terminated by the electron donated by ascorbate ion. Vitamin C tablets. Vitamin C is sold in the market as tablet of 500 milligram by various pharma companies such as Sunkist vitamin C chewable juicy orange tablets. It contains 500 milligram vitamin C, that is ascorbic acid. Saline, most usual brand of vitamin C, and the most popular brand of vitamin C is LMC. Determination of mass of ascorbic acid in vitamin C tablet. The mass of ascorbic acid in the given vitamin C tablet can be determined by titrating its solution against a standard 0.005 m iodine solution using a starch as indicator. The mass of ascorbic acid in the given vitamin C tablet can be determined by titrating its solution against standard 0.005 molar iodine solution using starch as an indicator. The appearance of faint blue-black coloration, light blue-black coloration indicates the end point of the reaction. Reactions involved during this titration. Ascorbic acid is oxidized by iodine to dehydroascorbic acid. The reaction is given below. This is ascorbic acid which reacts with I2, forming dehydroascorbic acid plus 2I minus plus 2H plus ion. This equation is balanced with respect to atoms as well as charge. Two hydrogen atoms are removed from these positions, forming a product which is known as dehydroascorbic acid. It is obvious that 1 mole of ascorbic acid reacts with 1 mole of iodine. When ascorbic acid is oxidized completely during the titration, the excess of iodine reacts with starch, forming blue-black complex. When ascorbic acid is oxidized completely, the addition of one more drop of iodine to the reaction mixture leads to production of blue-black coloration due to formation of a complex compound between a starch and iodine. It is an inclusion complex. Reagents required: 0.005 molar iodine solution is required for the titration. For the preparation of this reagent, 2 gram of potassium iodide and 1.3 gram of iodine are dissolved in distilled water, and the volume is made 1 liter, and thus we get 0.005 molar iodine solution. Let us find out the number of moles of iodine in 1.3 gram. Number of moles equals to mass divided by molar mass. The molar mass of iodine is 254 gram per mole and its mass is 1.3 gram, and hence the number of moles comes to be 0.005 mole of iodine, which has been dissolved in 1 liter solution, and the number of moles per liter is called molarity, and hence the molarity of iodine solution is 0.005 m. Here, one fact is noteworthy that iodine is almost insoluble in water. But in the presence of potassium iodide, iodine dissolves in water, forming triiodide ion. Iodine solid does not dissolve in water, but in the aqueous solution of potassium iodide, it dissolves, forming aqueous solution of potassium triiodide, and hence Ki is taken for the preparation of solution of iodine. And 0.5% starch solution is to be prepared, which is used as indicator. For this purpose, 0.25 gram of soluble starch is added to 50 ml of boiling water in 100 ml conical flask and stirred well to dissolve it. It is cooled before use, thus we get a starch solution whose strength is 0.5% because 0.25 gram has been dissolved in 50 ml, and hence 100 ml of the solution will contain 0.5 gram starch, and hence its percentage strength is 0.5%, and this solution is used as indicator. Procedure: the given tablet of vitamin C is weighed accurately and dissolved in 100 ml distilled water. The solution is filtered in a 250 ml measuring flask and the volume is made 250 ml by adding more amount of distilled water. Thus, 1 tablet of vitamin C, which has been weighed accurately, has been dissolved to get an aqueous solution 250 ml. 25 ml ascorbic acid solution. This solution is taken in a conical flask, 250 ml conical flask, and 1 ml starch indicator is added to it and shaken well. 1 tablet of vitamin C is dissolved in distilled water and the volume is made 250 ml. 25 ml of this ascorbic acid solution is taken in a conical flask of 250 ml and 1 ml starch indicator is added to it and shaken well. Then the solution of conical flask containing ascorbic acid solution and a starch indicator is titrated against 0.005 molar iodine solution which has been taken in the burette. The end point of the reaction is indicated by the appearance of first permanent trace of blue-black coloration. When first trace of permanent blue-black coloration is obtained, the end point of the reaction is indicated. The titration is repeated until two concordant readings are obtained. Color changes during titration. Vitamin C tablet solution plus 1 ml starch solution, 25 ml vitamin C tablet solution is taken in the conical flask and 1 ml starch solution is added to it and shaken well. The solution of this kind is obtained. 0.005 molar iodine solution is taken in the burette and it is added drop wise to the conical flask. Iodine reacts with ascorbic acid. Iodine is consumed to oxidize ascorbic acid to dehydroascorbic acid. This is the color before end point. This type both are equivalent. At the end point, permanent trace of blue-black coloration is obtained due to when the entire amount of ascorbic acid is oxidized to dehydroascorbic acid, the addition of 1 drop of 0.005 molar iodine solution leads to the reaction of iodine with a starch forming faint blue-black coloration. And after this endpoint, the addition of 1 more drop of iodine solution leads to this coloration. But we have to note down the burette reading at this point. This is the end point of the reaction, and after the end point, addition of iodine solution leads to more dark blue-black coloration. Calculations. Mass of vitamin C tablet, let it be W milligram. 25 ml ascorbic acid solution requires V ml 0.005 molar iodine solution. Let it be the titer value, concordant burette reading. 25 ml ascorbic acid solution requires V ml of 0.005 molar iodine solution for complete reaction to attain the end point. Therefore, 25 ml ascorbic acid solution which contains 1 tablet of vitamin C will be equivalent to 10 V. It is 10 times of 25 and hence it also be 10 times of V. 10 V ml 0.005 molar iodine solution. And this on multiplying by 10 is equal to 0.05 ml molar iodine solution. And on transforming it into mole, it will be divided by 1000, 0.05 V divided by 1000 mole of iodine. And we have already seen that 1 mole of iodine reacts with 1 mole of ascorbic acid, and therefore we same number of moles of ascorbic acid will be present in 250 ml ascorbic acid solution, that is 1 tablet of vitamin C. And the molar mass of ascorbic acid is 176 gram per mole, and hence this number of mole can be transformed into mass by multiplying with 176, and it is gram of ascorbic acid. And on transforming gram into milligram, we have to multiply by 1000 will be cancelled out, and these two terms on multiplying give 8.8. 176 multiplied by 0.05 is 8.8 V milligram ascorbic acid, which is present in W milligram, that is 1 tablet of vitamin C. Percentage of ascorbic acid in vitamin C tablet is equal to mass of ascorbic acid in the tablet divided by mass of tablet into 100. Mass of ascorbic acid in the tablet, as we have calculated earlier, 8.8 V mg divided by mass of tablet Wmg into 100. Mg will be cancelled out, and it will be 880 divided by W. This is the percentage of ascorbic acid in vitamin C tablet. Here V is the volume of 0.005 molar iodine solution in ml, which is required to react with 25 ml vitamin C solution. W is the mass of vitamin C tablet in milligram. Thus, by knowing the values of V and W, the percentage of ascorbic acid in the given brand of vitamin C tablet can be calculated easily. Oxidative damage of cell by free radicals. Our cell membrane, that is membrane of the cell, is made up of polyunsaturated lipids. This lipid, that is our cell membrane, that is our cell, is damaged by free radicals and O2, resulting in the formation of lipid peroxides. These lipid peroxides are called lipid oxidation products, and this takes place through a chain reaction. Our cell is covered by a membrane which is called cell membrane, and it is made up of polyunsaturated lipids. This lipid is damaged by free radicals and oxygen, resulting in the formation of lipid peroxide through chain reaction. It is called lipid peroxidation reaction, or oxidative degradation, or oxidative damage of lipids, that is our cells, and its mechanism is as follows. Polyunsaturated lipid, which constitutes our cell membrane, has two double bonds, and this is methylene group attached to two carbon-carbon double bonds. Hydroxyl free radical, this is free radical, abstracts this hydrogen atom along with electron with the elimination of H2O molecule. It results in the formation of lipid radical. This is a lipid radical having one unpaired electron. It undergoes rearrangement, forming a rearranged lipid radical. This has unpaired electron at this position. The position of unpaired electron has been changed, and it leads to the formation of conjugated diene. It is isolated diene which is less stable, is transformed into conjugated diene, which is more stable, and hence this rearrangement reaction takes place. This free radical, this unpaired electron, abstract O2 molecule. O2 molecule also has two unpaired electrons, and a bond is formed between carbon and this oxygen atom, and one oxygen atom, one unpaired electron is present at oxygen. It is lipid peroxyl radical. This lipid peroxyl radical reacts with another molecule of polyunsaturated lipid, leading to the formation. This hydrogen atom is transferred along with the electron on oxygen free radical, leading to the formation of lipid peroxide. This is lipid peroxide, lipid oxidation product, and during this process this lipid radical is regenerated and a cycle is completed. A chain reaction propagates. This lipid free radical again transforms into lipid peroxide, and this chain continues. Even one hydroxyl free radical can transform a number of polyunsaturated lipid molecules into lipid peroxide, and thus our cell is damaged. It is called oxidative damage or free radical damage of our cell membrane. Chain termination of lipid peroxidation by ascorbic acid. The above chain reaction of lipid peroxidation reaction is terminated by ascorbic acid, and therefore ascorbic acid acts as antioxidant which prevents our cells from free radical damage. This is a lipid radical. It is less stable and more reactive. It is ascorbic acid molecule. This hydrogen atom, along with its electron, is transformed at this position, forming lipid, and more stable, less reactive ascorbyl free radical. This is ascorbyl free radical. Thus, the chain reaction of lipid peroxidation reaction is terminated, leading to the formation of lipid and more stable ascorbyl free radical. Now the time for self-assessment. A vitamin C tablet weighing 651 milligram is dissolved in distilled water to prepare its 250 ml solution. 25 ml of this solution requires 30.2 ml 0.005 molar iodine solution for complete reaction. During its titration, using a starch solution as indicator. Calculate the percentage of ascorbic acid in vitamin C tablet. And next question, how many chiral centers are present in ascorbic acid molecule? Indicate them by asterisk. Thank you for watching the video with concentration. Please like if you find this video useful to you, share to your friends for their benefit, and subscribe my channel if you have not subscribed it, so that information regarding my new videos may you get in time. Thank you again.